now that you've either filed or milled, like I did, these particular positions, and you've counterbored the center ones, you then need to fit the nuts in and the cap screws. Just fit them in by hand, that's no problem. For the ones in the middle, you can just put your tweezers in, drop them in, hold it with your finger, turn it upside down, push it down, open it up so as the threaded part is lined with the hole. Then just with your Allen key, nip it up. Now what you have to do is make sure that all these are parallel. So then with the file that you've used to file all that down, just line them up, push them in, down like that, and they'll be all parallel. And for the ones in the middle, just put your file in and push it on the side, and then that will be nice and parallel. Small printed holes around the 3mm, they get a bit of overhang of filament, that sort of thing. You can use a drill, but a drill will tend to cut more than what you want. You really just want to remove the bit that's sticking up. So get yourself a small rat tail file. There's about a 6-inch one that broke off, and you can just easily just file those in, remove the bit that's sticking out, and all sweet. So once you've used your files and your tweezers, it's then time to fit your 20 by 20 extrusion. The reason why it's parallel, you can just put it in like that. The reason there's a problem with these end brackets, the design was for the original hex nuts, and if you look at the manual, which is fairly crappy, you see that it says you put the hex nuts and then you have to slide this in like that and make sure they're all lined and all that sort of thing. They then come up with the proper nuts for the extrusion, but they never modified their drawings to reduce that height down. So that's why you have to do the modification. So then it's just a matter of putting it in, getting your Allen key, nibbling it down till you actually can see it below the surface, rotate it to tighten it up, and because it's in the 90 degrees it will lock in position, and then you can just nip it up. That's how quickly it's done. Make sure it's sitting flush down there, flat on there, and then you can then go on and do the others. So if you manage to remember how many turns it takes to loosen off, then you can do the same. So you can easily just do a bit of mass production, line them up like so. Make sure you've blown all these first when you remove the sticky. Set them in position and then nip them up. For the longer ones, you should do the banana test first. What is the banana test, I hear you say? Well, if you have two together, they can be curved, but they still look flat. So to do the banana test, you turn them upside down in all directions, and you'll soon see if something is not flat. And the reason for that is the carriage travels up, So it's curved. The double type printer uses mathematics to work out its position, and so if it's curved this way, 1 millimetre or 2 millimetre, it thinks it's 1 millimetre this side. So the calculation's out and your sides won't be parallel, circles won't be round. So the banana test is simple. Just put it on there, give it a little tap, put it up to the light, and you'll see there is actually a bend in there of probably 1.5 millimetres. So what you do, you try to rotate it around and find it the best parallel position. So that's parallel that way. So that's parallel that way, parallel that way. Do your third one with your second one. That's parallel that way. I often wondered why they actually come bent in that, but I've seen a truck carrying lengths of steel and all that, and when they tie it down, they just use the turnbuckles and they actually bend it. They're more concerned about the load not coming off the truck than what they are supplying parallel piece of material. So then when you come to fit those in, you can say the parallel sides, because the moves that way the most, it will fit in and have the least amount of error. You'll still have an error this way, of course, and over that length it's 1 millimetre. So, and if you file these correctly and you've lined the pins up flush to the bottom, that's why you file. Or if it is a bit tight, you can, like I said, put a flat washer, get your various sizes M6 bolts and tighten it up, and then you'll just tighten it up and you'll just pull it in, and your longer bolt will pull it up. Then when that runs out of thread, you put the next one in. But if you file it correctly like I've suggested, and they are difficult to pull off, as you can see, that's how you fit them. Now I can either tighten these up, film it, put it on a fast forward, and you can enjoy that fast movement, or you can use that time to work on your equipment, and I'll just nip these all up together and assemble it and then get back to you after that. You need to place these corner brackets facing in the right direction. They work in two directions, but the K on the Kossel needs to be on the bottom. The shiny part is the bottom, and the reason for that is if you want to access the wiring slots on the side, you need to make sure that you've got the holes, the clearance holes, up the top. So there's holes either side, so you can just run your wiring down the tube into the hole, out through the side, and then in through the slot in the bracket, then into the centre area here. Or run your stepper wires in, through and up when you decide where you're going to have your electrics, either up the top or the bottom. I've decided to the bottom, and this is the power supply.